Guys, we're gonna, whoa, let's see if I could make these go over here. Maybe step back here, I don't know. What the hell am I supposed to do with these? All right, can you hear, well, you could hear me without these if we had to. We're gonna get started in just a minute here. I'm waiting for the video team to tell me we're good. First of all, good morning to everyone. Thank you for coming. You know, I forget, because I don't live in the city anymore or in the New York area. For people who don't live in Manhattan, it's a struggle. The struggle's real getting in on time in the mornings and stuff like that. So we're expecting, I don't know, 4 times this many people, but I guess, you know, we'll see as they come in during the day. I wish these were a little lower. I'm not quite sure. Okay, so my name's Alan Schimmel. I'm the CEO, founder of Techstrong, and we're the folks behind DevOps.com and Security Boulevard, Cloud Native now, Techstrong AI, Techstrong TV, and a bunch of other properties. I'm going to introduce our panelists in a second, but I want to spend a little time talking about platform con and platform engineering. You know, I first became aware of Platform Con about 2 years ago. And they captured much as when DevOps first started 12 years ago, 13 years ago. There was this groundswell of a community around it that was attracted by the idea of what the core of what platform engineering is about, and we're going to talk about that today. Like too many other things in technology, marketing maybe hijacked it a little bit, and there was a lot of, you know, running around, DevOps is dead, long live platform engineering, and this is going to be the replacement for that, and this, and, you know, that's marketing talk. But nevertheless, platform engineering, I think, has established itself as part of today's pantheon of technologies that we use in app dev and or you want to call it DevX, application development, or just development. But it's one of several, right? It's one of several kind of technology and frameworks that we are all dealing with. In the meantime, Platform Con has continued to grow. I think, and it's going on all this week. I believe it started Monday and it'll run through Friday, so we're dead in the middle. There's actually a big in-person element, because PlatformCon was always virtual. This year they tried to do some in-person elements of it, and there's a big one going on in London, I think 300 people or something. And then there's smaller ones in New York here, in Austin, Texas, in the Bay Area. I'm not quite sure how big those are, but the idea was to do these satellites, and somewhere along the line they became watch parties, but it's not, I don't make Platform Con, so I apologize that, you know, I don't have a lot of control over that. But the good news is we are going to be able to, we have 2 presentations from Platform Con that we're going to be doing today, plus we're doing this live panel, and then I'll be doing a fireside chat with my friend Francois here, who's one of the co-founders of CloudBees. So we have a full day of sessions. Well, we'll probably end sometime after lunch. So, you know, we'll have you out of here, I'm hoping by 1:30, 1 o'clock, something like that, depending how long we run. But we have, whether a lot more people show up, and we have, like I said, maybe 40 people registered, it's going to be an intimate gathering. It's not really just about us sitting here. It's about you in the audience getting involved too. I'd love to hear what your impressions are around platform engineering, around DevOps, around SRE, around DevSecOps, right? All important concepts that we deal with day to day. So don't be shy about participating. We have mics to go out here if you want. We are recording and streaming this, so you'll be able to watch it later for whatever you miss or you want to go back to. That being said, I should also mention that on Friday, the 14th, yes. Okay. On Friday, the 14th, we are doing another panel that is being streamed out into the Platform Com audience, and Hope here will be participating in that with me, as well as a couple of folks from Europe. So if you have time Friday, if you go on the Platform Con website, you can register, it's free, and you can catch that webinar or panel, it's not really a webinar, panel live on Friday. Good? All right, with that being said, let me jump into our first panel today. I know originally it was advertised we were going to have Brian Fox from Sonotype here, but unfortunately Sonotype, well, Brian couldn't make it here, and I was going to do it as a fireside chat with Hope, but I want us all to give a round of applause here to our volunteer that we took from the audience. And I'm going to try to get his name right. It's Shazab Naqvi. Shazab Naqvi. Shazab is also with Cloudbees with Hope, solutions engineer. And he volunteered to come up here cold and work on this. So you got to give him credit for that. And thank you for doing that, Shazab. Okay, our first topic today is making sense of the app dev landscape, right? It's a very different landscape than when I first got involved in IT 30 years ago, right? Developers worked over here, operations folks worked over there, security folks, I don't know where they worked, but they did work somewhere, probably in the bottom, in the basement, in a very dimly lit little room, and they liked it that way. But there wasn't this sense of team across the entire software development lifecycle, as we call it now. You know, and then about 25 years ago, Agile came on the scene. And Agile was a revelation for developers, right? It really didn't affect the ops folks as much, certainly didn't affect security very much, but maybe testing and developers. Agile, in my mind, so it kind of represents a, no pun intended, a waterfall or a watershed moment, right, of doing things differently. And, you know, about 13 years ago, we saw DevOps. Patrick Dubois coins the term DevOps, and we start to get this idea of dev and ops working together, right? Now, we're going to talk about this, and I'm sure you guys have some thoughts. For too many organizations, that DevOps just became a lot of shifting left, which is not necessarily a bad thing, but shifting everything onto the developer. And I think a lesson we've learned over the last 13 years is you just can't put everything on the developer. They're not the security person. They're not the testing person. They're not the ops person. They're the developer. You need a DevOps team. It takes a team. We also put throughout the whole 10 years ago, I started DevOps.com. And over the last 10 years, there's been this undercurrent of, well, what about ops? Is DevOps too development-centric? Is it too heavy on the dev side? What about ops? And we've been searching for the new ops. And I've heard it called new ops, no ops, you know, many different ops. We saw the rise of SREs, right? Now, SRE, you know, started as a Google thing, a great book and all that. But SREs are real, and the movement from SLAs to SLOs has had an impact in there. And then, like I said, maybe just 4 years ago, 3.5 years ago, we've seen platform engineering sort of become a thing, a real thing. And it's become, I mean, if you look at the Gartner hype cycle, it's a real thing. It's ascending. It's not at the top of hype. It's only about halfway, but it's ascending. So I've asked Hope Lynch, who I've had the pleasure of doing many a webinar with, but this is the first time we've been on the same stage in person. So Hope is up here from Raleigh. And as we mentioned, Shazab's volunteered to come on here to talk about how do all of these things fit together. Agile, DevOps, SRE, platform engineering, or do they not play well together? Do they not play nice together? Are they causing more conflict within our app dev, within our IT teams and development and deployment teams? So, Hope, I was going to let you open up, and I kind of set the stage. Tell us your thoughts on that.
I think it's a little nuanced. So from organization to organization, the experience can be very different. There was a recent article I saw that said in Europe they'd done a survey where they found that waterfall projects are more successful than agile projects. But it's somewhat subjective, because if the organization does not implement Agile well, or DevOps well, or SREs don't have their practice set up well, you will see a high failure rate. All of these things do and can work well together, but you have to make it into a system. So the software development lifecycle is a system. And if you have each of those pieces doing their own thing, so let's say the SRE practice is absolutely perfect, they will run into problems when they get to the DevOps team if their practices aren't good, if the Agile team's practices aren't going that well. So basically, the better the overall machine is, the better their practices can be, and I do believe that they can work together very, very well.
Shazad, what do you think?
Sure. Just to kind of piggyback off of what Hope was talking about, I think one of the key things across the SDLC is having that visibility. Each player, each individual understanding what are the inputs, how are these artifacts being developed, how are they being, built, what are the, the test cases, the security results, and then being able to build, the entry and exit gates across your SDLC. Because again, when you're doing that, there are different players who, again, manage, who does your compliance? Is it the developer who makes the compliance rules, or is it the security and compliance team, right? So now they have an input, okay, well, to get from dev to QA or QA to prod, these are for example, the SAST and DAST testing. These are the results I'm looking for. Now, it's up to the developer or the platform engineer or the DevOps shared services team to maintain and say, okay, these are the test cases that are going to be running, and these tests now are going to be validated and approved automatically, hopefully, by the rules that are being built by, developed by the security teams.
Yep. So I think when we talk about all of these different kinds of technologies and frameworks, some of them certainly play better with each other than others, right? So to me, there's always been a natural affinity from Agile into DevOps, right? When we first started DevOps.com, that was the tagline we had. DevOps picks up where Agile leaves off, right? And it went like that. I think SRE also has that natural affinity, obviously, to, it's further right on that shift left, timeline of the SDLC. Testing's been a bit of a ping pong ball through all this, right? Do we want our developers to test? Do we want our testers to test? Well, we want our testers to design the test, but we want to automate as much of that testing as possible. And if we're automating it, how do we kick it off? And is it the developer who kicks off testing? Or is it still the tester who kicks off testing? Who decides when testing is passed? And again, we want to automate that. This, automation is a double-edged sword, because in many ways, I think automation drives all of these conflicts, if you will, at the boundaries of these areas, because let's face it, automation is code for taking humans out of it and doing faster without being slowed down. And in our quest to do more faster and automate and take the humans out of it, I think it creates a lot of these conflict zones. I think platform engineering had a great idea behind this, which is, hey, if we set the the environment right, if we put our guardrails in place, then we could let all these folks, the SRE, the developer, the tester, the security folks, if we have the guardrails and that platform set up, you know, we could let these cars go around that racetrack as fast as they can. We could automate the heck out of it. I don't know if that necessarily always works out that way. What do you guys think?
So I want to backtrack just for a moment, because you said something that struck a nerve for me. And I am very opinionated about this. When it comes to testing, I have worked with and managed engineering teams where they wrote their own tests, but then the QA team ran tests against the very same things. And it has always bothered me that there was not somewhere someone saying, how many times is the testing team actually finding something? Are they just there spinning their wheels? So at one employer where we had a platform team, and test was not under my purview, but I influenced them to prioritize the end-to-end testing before production. And let's back up a little bit on the tests that the developers are running. Running those again in QA was such, it was just so much overhead, right? So that's my thing. I am in favor of QA focusing more on end-to-end testing in conjunction with the platform engineering team to report those results versus QA being the team that has to test every user story, everything that developers push. But with that said, yes, the guardrails to be able to, as you stated, run around the track as fast as they want, those golden paths, those guardrails for the engineering team, it's a very good thing, as long as it doesn't feel like Big Brother and some, you know, top-down authority that is clamping down on the creativity of the development teams and those people who are involved. If it is, we've put these guardrails on because we have ensured that the platform is secure. We have authorized applications. They're hardened in the right ways. Then it's great and it's helpful to everyone, as long as it's not overreach.
Fair. Shazad, any thoughts on that?
Yeah, I was just going to add, you're right, Hope. Let the developers do what they want, and they're, you know, however they want to do their testing, whatever it's, you know, if they want to use SonarCube or, you know, Veracode or some other SaaS solution to do their security static code analysis. But once you move to the right side of the SDLC, you want to ensure, hey, did you run a scan, security scan? I don't care which scan you chose, but did you run one, and what were the results? And then, again, that's how you build those guardrails. And then, again, as you move more to the right towards production, you have a lot more efficient code that you know has gone through the, you know, the rinse cycle.
So my problem with this, though, and I'm sorry I have a problem with this, is that surveys show developers spend somewhere between 12% and 25% of their time actually developing, coding, right? Developers don't want to really run SAS and DAS testing. Developers don't want to be QA testers. They want testing to be done by QA. They want security to be done by security. Not that they want to deliver crappy code or low quality code or untested code. But that's not their job.
Yeah.
And right there, in a nutshell, I think is the problem that DevOps has run into. And as someone who, I'm DevOps.com, that's the problem we have, is we can't just say, let the developers do it. Developers want to develop. And that's what they do best, and we pay them a lot of money to do it. And I think that's given rise to this whole platform engineering idea is, hey, let's put everything in place here so it's not all on the developers to do this.
Agreed. However,
Okay.
I think the developers should do some testing, but not manual testing. right? Like you said, automate all the things. Automate as much as possible. If the teams that I manage were sitting there writing manual tests every single time, yeah, we would have had a lot of issues and we would not have gone to production on time. But I think there is a balance. They need somehow to validate that the piece they have added to the whole doesn't break the whole, that it works with the other things. If they have branched to something and they need to merge it back in, does it actually work properly without testing it in production and bringing everything to a halt? So having them do some testing, I don't think it should be half and half, but automate as much of the testing as possible. And then, again, for me, relying on end-to-end.
Yeah, so one of the things, we talk about shifting things left. I think we shifted the tools and the function left, but we didn't shift the people left, right? So in a Scrum team, you really should be making sure that you have a security person on your Scrum team, you have a QA person on your Scrum team. So when you're building and you're planning things out, you take into account things like how long would it take to do the security? What type of security do we need to do? If we're doing testing, what type of testing needs to be done? So then when you're coming up with your planning and your JIRA tickets, whatever else, how long things are going to take to develop, you take into account those, use the experts that are in that function as part of the Scrum team, right?
So Shazad, do I include SRE people in
Yeah,
that
you should,
Scrum
definitely.
team? Do I include platform
I
engineers
would,
in that
right?
Scrum team?
As we go towards, and we've been trying to go towards cloud native for a long time, you're having a lot of now dependencies that are being built in, and the only experts in that are the SREs.
I agree with you, and I think platform engineering has to be involved in that. Hope, I'm going to come back to you here on a Cloudbeast specific question. So how does, Cloudbeast, in my mind, is one of the, founding companies around DevOps, right? They were the Jenkins, still are the Jenkins company, though I know the new platform is not Jenkins dependent. But Cloudbeast, we think Jenkins. With Jenkins, you think DevOps, right? It kind of gave rise to all of that. How does Cloudbeast, as such a, important part of the DevOps community, how do you guys support, let's say, platform engineering?
So for us, we see our products as being a central part of the toolkit of a platform engineering team. So platform engineering teams need IDPs. We provide an outstanding option for an IDP for the platform engineering team to be able to serve their developers. And also when they look at products that they can use on a large scale, in an enterprise scale, perhaps with sometimes with a few hundred developers or with thousands of developers, it can be hard to find a tool that they can scale that broadly, that works reliably, consistently, and also gives time back to the development teams. So for a platform engineering team that is treating their developers as customers, our tools are an excellent option.
So there are some folks in the platform engineering community who say, look, the reason we need platform engineering is that DevOps alone doesn't scale when we get to 100+ developers. Now, I know Cloudbeast has many enterprise customers that have hundreds, as you said, if not thousands of developers. Is that true, you think, or?
I think it is like anything. You start to hit economies of scale. We have shared services teams in organizations because it is hard to unify across a large organization and ensure practices are consistent. And you waste a lot of time by trying to have individual teams network and connect. I don't know if you've ever seen one of those communication frameworks that shows how many more branches and communication paths you add every time you add one more person. And at a certain point, that becomes too fragile and it falls apart. So scaling in that way to say that there is a central body to ensure that there is some consistency and that you can scale, it's not a failing on the part of the organization. It's actually a great step on the part of the organization, because now they are taking work that would, for some people, would just honestly feel like busy work, coordinating all of that and centralizing it to a small team that, with the right tools, can scale pretty broadly.
Shazad, you're out here in the field talking to real live customers, right, as part of your role. Where do you see kind of the intersection with platform engineering, especially when we start talking about like like the highly regulated industries, as we call it, finance, government, healthcare? Does platform engineering help with that? How does CloudBees kind of work through that?
No, it definitely does, right? So one of the oftentimes we're faced with is, the situation where developers are maintaining some sort of build environment, some sort of, like a Jenkins instance, right? And so there's disparity across organizations, developers doing, building, maintaining different tools. And I was a developer at one point, right? And the last thing I wanted to do was maintain a tool, right? So for me, I want to be able to write code, and I want to be able to, have my code run. I don't care what build solution is using. At the end result, I want to, in my IDE, I want to say, hey, your build passed or failed. This is where kind of the platform engineering team, shared service team kind of come into play here, where, they bring that stability across that platform. So when I commit my code, it gets built, and if there's any dependencies that need to be built along with it when it comes to deploying, that's all being maintained by the SRE or the platform engineering teams.
Hope, thoughts on that? Around highly regulated industries?
I think it is a great risk avoidance practice for a highly regulated industry to have a platform engineering team. There are so many requirements that they have to meet, and audit trails, other things like that, right? That consistency is something that they need in order to report in a timely manner, report consistently, and also to ensure that they're not raising unintentional flags, I think, with the auditors just due to errors that may come into the system. So highly regulated, having a platform engineering team, I think it's a wonderful boon.
My next question is, okay, it's easy for us to sit up here and talk about DevOps and platform engineering and SRE, but you know what? For people who do this for a living, like many of you, those are all terms, but where does the rubber meet the road? Where does, right, what are you supposed to do, right? I can't be just, a jack of all trades here. I can't be an SRE and a platform engineer and a developer and a QA, but yet I have to know about these things. And I want my vendors, my partners, my tool vendors to kind of make it easier for me, if you will, right? To kind of give me that ramp on and help me achieve and be successful, right? Otherwise, I got to look for a different vendor. So I'll throw this to both of you, right? How does, for instance, you're both from CloudBees, so you can talk about CloudBees. It'd be very hard for you to talk about JFrog or something else, but how does a vendor like CloudBees help today's teams, and specifically developers, in terms of engagement and being productive, right? And what are I don't want to say KPIs, but what are the right metrics that they should be following to see if all this works together?
So I will offer that one thing you said made me think of. So going into an organization and trying to make sense of everything and figure out who needs to do what and which teams work together. CloudBees, we do a service for value streams mapping, right? So that they can start to understand and get some insight into how the different parts of their organization work together. In that, there are conversations with people who are on or work with the development team, and Shazab can tell you much more about this than me because he does it more often. But in that, we are actually listening to hear what is important. So when those metrics are being formed, it isn't that you take the exact same metrics out of a box and say, here are the metrics that you need to track. Each organization will prioritize different things, and those metrics should reflect the goals of that organization. There are basic metrics like DORA, others like that, but within that organization, it could be they need metrics for improvement. Maybe there's a pain point they have. They will track that metric for a year. Then it goes away. Something else may take its place. But it should be based on the goals of the organization and the goals of the development teams.
Agreed?
Yeah, so we typically in the field, we baseline their current process, and then from that baseline, we determine, okay, these are the areas where you have your bottlenecks, and based off of those bottlenecks, then we come up with a templates and out-of-the-box dashboards that they can customize, and that's key. Customization is very key because, like Hope was mentioning, DORA metrics are great, but each organization, how they measure, what data source is all different, right? It could be Jira, it could be Rally, it could be, if you're doing flow metrics, well, what tool are you using? And how do you determine mean time to recovery? Is it a ServiceNow ticket, or are you following a Jira ticket? Again, it's dependent upon the different customer. Now, the other thing that we do is once you have the metrics, then we start to look at, okay, let's see if we can improve on your process. And once you start looking at that process, we kind of work with your team and develop where it could be orchestrated, where it could be automated, and if it needs to remain manual, how can we make that more efficient, right? Can we automatically create the ServiceNow ticket for you versus having a developer going in and creating a ticket? I mean, as a developer, that's the last thing I want to do. Close Jira tickets and open up ServiceNow tickets, right? If that could be automated, and then we can serve that up as a template or a self-service catalog in your IDP for developers to go ahead or develop anyone, right? Different roles that you have in your organization to spin up or, build out from these templates. That's probably where I would lead with.
Yeah, it would be interesting. We have a small sample here, but how many of you would consider yourselves developers? Don't be shy. Okay. And how many consider yourselves other than developers, right? So you're both. Okay. So it's actually about half and half. Now that's normal for DevOps. It's normal, like when I do cloud native type of engagements with people, from cloud native now. We see that kind of, that's how, that's what DevOps is about. Anybody here consider themselves maybe a platform engineer? You too? He's everything. This is the Renaissance guy over here. So I'm going to give you, I'd like to hear from you folks, kind of your thoughts about what we're talking about here, right? And then bounce it both off of Hope and Shazab. It's still a new name for me, give me a day. Hope and Shazab, and see how this all plays in. Let's start with Leonardo da Vinci, the Renaissance guy first. I'm going to grab your mic. So you're a developer, an ops guy, and a platform engineer.
I guess I started as a developer, and then I spent a couple of years as DevOps, and the past 2 years, mostly platform engineer. So I got lucky to see all perspectives, so I hope it makes me maybe a better platform engineer just because I saw the pain of developer who doesn't need to know so much of the background of things.
So, as a platform engineer now, are you making developers' lives platform engineer, are we making developers' lives easier?
I think that's what we have to. That's the whole reason.
That's the purpose, but
Yep.
are you?
Yeah, I think so. Well, definitely. We have been spending quite a bit of time with customers to see how we scale, right? Essentially, most financial. I work mostly with financial customers, but most customers have a very small team of DevOps people who knows cloud, but not necessarily cloud. They know operations very well, and the majority of developers, above 80%, are application developers, people who write business logic. And the gap is for them to upskill everything about the cloud is, well, we want that to happen, but it's going to take time. So until that happens, how do we make them scale? How do we make them able to use things in a proper manner? Security, resiliency, all the things you guys discussed. So.
Absolutely. Thank you. You guys are going to have to share a mic. Any thoughts on that? Otherwise, I want to ask one of the developers, you raised your hand as a developer, yeah? Hold on, you got to get the mic. No.
So, I come on stage?
He's not shy. Look,
I'm not shy.
Absolutely, we're live streaming. Thank you.
Oh, you're welcome. So, I said that everybody is a developer today and has to be a developer. Doesn't mean that I has to be a full stack developer. I'm not a full stack developer, right? Yeah, exactly.
We need full stack developers, right?
Yeah, so again, yeah, we do need full stack developer. So again, the mindset has to be a developer. My background, platform side, evolving into DevOps from a developer-centric mindset, SecOps altogether. One of the things which I just wanted to add with these two folks said, with SecOps and everything evolving, right? I mean, DevSecOps is the new buzzword. Forget about DevOps, right? So, in a big enterprise, and I work for Prudential, right? To really make SecOps, DevOps, DevSecOps evolve, you really have to change the cultural mindset, right? If that is not there, security champions, we heard the buzzword. If that's not there, then yeah, you're really making developers work all night to take care of security while they develop also, right? So that whole cultural mindset has to change, which is what we are struggling with, and that's one of the real things which I see to make it a success of DevOps, DevSecOps, platform engineering all coming together and making everybody's lives easy. That cultural mindset has to change, right? That's a big thing.
I agree. Hope you have thoughts on that.
I have so many opinions on that, and we should speak. So one of the, let's say, misconceptions is that there is one culture for everyone for DevOps. That is not true. If you want to find out what your culture is, there is a handy dandy tool called the Competing Values Assessment, and it breaks it down into 4 different cultures. You can make DevOps work in any of those cultures. You just have to know the one that you are in so you aren't working against it, right? So if you haven't done some sort of cultural assessment and you're trying to shift the culture, you may end up where you don't want to be, right? But yes, aligning on culture definitely is critical.
Can I just make my comment on that? You're absolutely right? And when I say cultural shift is basically, yeah, security was an afterthought, right? Now it has to be embedded into your DNA while developing, right? So that's what I meant, right? But the other thing which I wanted to add was, bringing shift left or shift right or building tools to the developers closer, right? What we are trying to do is, forget about the tools itself, right? Everything should be a service. So while the developer builds and uses those services, right? Whether it is SaaS or DAST or SCA, right? They are not worried about the tools itself because the underlying tools will change and evolve. All they're using is a service in the IDE itself, and then they don't have to worry about anything else, right? So that's basically platform engineering evolving at that stage, right? That's one of the core things which we are trying to build to in the future.
Again, good. were you a developer? Who raised their hands as a, now we scared them because we brought them up on stage. You don't have to come on stage, but I'd like to get a developer's point of view here. Is platform engineering, DevSecOps, are these things helping you? Are they least lowering the burden and allowing you to spend more time developing? I think that's really a question here. Anybody who are developers have, I know you're itching to say something. Go ahead.
For the DevOps, I agree. Like Platform Con is going to help us as a developer. So as he was telling me, I'm not a full stack developer, so it definitely, other than developing work, we have to do other stuff like taking care of a lot of things on top of it. So I would say like 30–40% is like developing work, and the rest is pretty much other stuff. So definitely I'm looking for Platform Con. That's what's going to help us to take care of our stuff and help us as a developer.
Thank you. So that sounds more aspirational, right, than today. But you know, so we're about 45 minutes into this discussion, and you know what hasn't come up? What hasn't come up is AI, and I'm surprised that no one here has mentioned AI, right? We talked about automation, we talk about security testing or any kind of testing, right? I think this is where the promise, again, the promise of AI comes into place where, you know, we talk about easing the burden on developers. It'd be great if while you're developing code in the IDE, you know, there's some sort of Copilot type of functionality that is testing code as you're writing it, that's telling you you're using the old version of an open source component, or there's some sort of compliance issue, or you know, the platform that you're using, this is not compatible with. I mean, there's a promise there, and more than promise, there are some solutions. I don't know if CloudBees has stuff like this yet, but right in the IDE before code even gets committed.
Yes, I think there's great potential there, and one of the ways it is already starting to play out. There are universities that are starting to teach computer science in a completely different way now. So instead of starting with the fundamentals of programming, they're already bringing AI into the classroom and teaching higher level concepts, because those lower level concepts they're considering as being something AI can help with, so why are we going to spend 3 semesters going through that? And in a similar way for the developers, now they also can spend time on higher level concepts, maybe more innovative things that they've wanted to work on. If the AI can write test cases, if the AI can sort of do pair programming with the newer developers, it frees up time, most of all, for them to be more creative.
Agreed. Guys, we're past 10 o'clock, so I need to end this. We're going to just take a quick 5-minute break because you're up next, right? And so trying to make this interactive and integrate it into the larger platform con. Our next speaker is actually a platform con speaker who had a pre-recorded session playing a platform con. We have the session, we're going to play it here, but then he's going to come up here and we could do live Q&A with the speaker, which is something you can't get on the virtual site. So let's take a quick, 3-minute break. We could load up his session, it'll play here, and then we'll bring you up on stage. All right? All right, we'll be on in 3 minutes. Hope and play, so first of all, let me introduce you to Sahi Ben Shabbat. Sahi is with AWS. He recorded a session for PlatformCon that's playing on PlatformCon. We're going to play it here for you, I hope. We have the MP4 file, we have the technology, I think it'll work. And the idea here is to play his session and then bring Sahi up here and he can tell you, give you some behind the scenes discussion as well as you guys can ask some questions. So we're trying to make this, this is not rehearsed, so hopefully it'll work. Guys, do we have the video queued? All right, let's kick it off and hopefully it works.
Hello and welcome to this session on unlocking platform engineer efficiency. My name is Anthony Watson, and presenting with me today are my colleagues Jim McVeigh and Zahi Ben Shabbat. We are all solutions architects at AWS who are currently focused on platform engineering. Over the last 18 months, we've been working with several customers on creating an open source reference implementation of a platform that makes it easy to deploy and operate workloads on AWS. Our project, called OPA on AWS, is based on Backstage. In this video, we will share some of our platform building learnings and designs with you. Our goal is to make this session valuable for everyone, regardless of whether you use a particular cloud or not. Although your company may have a unique definition of what a platform engineer is responsible for, based on conversations with customers, we have observed that they are often focused on the following things. First is identifying patterns, best practices, and technology stacks that meet their organization's needs. Security and scalability are important things to consider when making these choices. Next, the identified patterns and best practices are codified into reusable templates and stored in version control. Following that, automation processes that create and configure infrastructure and deploy applications are created. Finally, the platform artifacts are published and documented so that they can be used. When done well, this step can streamline application development and make it so that platform engineers are not a bottleneck for platform consumers. Faced with these challenges and many more, it can be hard to know where to start and how to organize and publish your solutions. I'll now pass the baton to Jim, who will talk through the approach we took to address these challenges.
As we just heard from Anthony, in a fast-paced cloud environment, platform engineering teams face significant challenges in scaling to meet the demands of application developers. Ensuring consistency, standardization, and maintaining security guardrails across multiple applications and projects and teams can quickly become a daunting task. So our proposed solution aims to address these challenges by leveraging the power of automation and a comprehensive platform engineering approach. Just like a developer portal with golden path templates can accomplish reusability and efficiency for application developers, we can do the same thing for platform engineers that are responsible for providing and managing the application runtime environments. At the core of this solution lies the concept of a source of truth, a centralized repository that houses the authoritative code, rules, and configurations for your entire application portfolio. One of the key aspects of our solution is the ability to collect and incorporate the preferences and requirements of application development teams. By providing a structured way for developers to express their needs, we can tailor the platform to better serve their specific use cases. By building upon this foundation, we introduce the concept of reusable abstractions. These abstractions represent high-level building blocks of a software system such as applications, runtime environments, services, and APIs. By encapsulating complexity and promoting modularity, we enable flexible and extensible solutions. Also, at the heart of our automation strategy are centralized pipelines. These pipelines are designed to orchestrate and automate various processes from continuous integration and continuous deployment, or CI/CD, to infrastructure provisioning and application deployment. By leveraging event-driven automation, we can streamline workflows and reduce manual intervention, ensuring consistency and efficiency at scale. Now, at any company, security is a critical aspect of a solution, so we want to integrate security measures into the core of each process, from code analysis and vulnerability scanning to role-based access control and auditing. A solution should ensure that security is never an afterthought, but an integral part of the entire development lifecycle. And finally, our solution includes automation for orchestrating templates. By providing a unified interface for managing and deploying templates, we can empower our platform engineers to create standardized and consistent environments while allowing for flexibility and customization when needed. All of these principles are in support of providing and moving towards a solution that provides self-service options for application developers so that they can create these secure and standardized environments in a cloud to run their applications. So let's take a closer look at a couple of these principles related to reuse, since that's at the heart of achieving platform engineering efficiency and addressing the application development team's needs. Now, at the core of this are our application blueprints. Defining an application's structure, dependencies, and configurations. These blueprints ensure consistent and standardized deployments with best practices and security guidelines built in. Runtime environment abstractions represent the underlying infrastructure and platform services required for application hosting. By encapsulating cloud resources, networking, and service configurations, we can enable consistent environments across teams and projects. And because we want to abstract the complexities of cloud-native resources, we introduce the concept of an abstract environment. Now, this is the component that can be exposed to users or application developers as the target for which they want to deploy their applications and services. We do establish a one-to-many relationship between the abstract environment and the environment runtime, and this provides us the option of deploying applications to multiple environments simultaneously to support SDLC environments like dev, test, and prod, or to support multi-region or multi-account deployment scenarios. Service abstractions define external services and APIs that applications depend upon, such as databases, message queues, and third-party integrations. This promotes reusability and seamless integration across applications and environments. Application abstractions define the contract and specifications for exposing application functionality, whether that's going to be traditional web applications, microservices, or APIs. These abstractions ensure consistency in design, documentation, and governance, facilitating collaboration and API-driven development. Platform engineers encapsulate concrete infrastructure resources into reusable templates, which are made available to application developers through a developer portal. Application developers can then consume these templates to provision applications and self-service runtime environments, accelerating their time to market by utilizing these standardized and secure environments. Another core part of an automation strategy is centralized event-driven pipelines, which orchestrate processes throughout the application lifecycle. So importantly, these pipelines should be built to be flexible and reusable through parameterization and are therefore stored in a common resources repository along with other reusable shared assets. These pipelines are triggered by events like code commits, pull requests, or even manual approvals, and this ensures seamless and efficient workflows. So these should be designed to be very flexible and reusable. Now, you may have many different types of pipelines associated with an application, a service, or an environment provider. Things like a continuous integration or CI pipeline is going to automate build, test, and analysis, ensuring code quality and security from the outset. It's going to integrate static code analysis, unit testing, and leverage common reusable pipelines whenever possible. A continuous deployment pipeline or CD pipeline automates application and infrastructure deployments, leveraging reusable abstractions and templates, thus eliminating the manual errors or potential for manual errors, and it's going to ensure consistency and accelerate time to market. An infrastructure provisioning pipeline is going to codify and automate the creation, configuration, and management of cloud resources. That's going to promote consistency, reproducibility, and version control. So it really reuses infrastructure as code modules that are also going to come from a common module repository. Now, other types of pipelines or jobs that complement the overall solution are going to be security and compliance pipelines, which ensure that security and compliance requirements are met throughout the application lifecycle. It automates tasks such as vulnerability scanning, configuration, drift detection, and policy enforcement. And this is going to provide platform engineers with a comprehensive view of your security posture. Centralized pipelines really provide platform engineering teams with higher abstraction, higher automation, and efficiency while maintaining control over common resources. So event-driven workflows in these pipelines provide that seamless integration with these reusable abstractions, and they empower our application development engineers to focus on higher value tasks while ensuring those consistent, secure, and scalable application deployments. To pull it all together, we see here a reference architecture that's going to provide a centralized Git repository of pipelines, infrastructure as code, and application source code. A Backstage platform for a developer portal is used to present templates and orchestrate scaffolding actions. An identity provider for access to the platform. And through plugins in the Backstage platform, we provide integration to a cloud provider, AWS in this case, and we have an ability to automate the provisioning of standardized and compliant architecture solutions. By adopting this type of solution, platform engineer teams can unlock new levels of efficiency, scalability, consistency, and security. With automation at the forefront, you streamline your processes, reduce errors, and accelerate time to market for your applications, all while maintaining a high level of control and governance. Now I'm going to hand it over to Zahi to walk through a demonstration of a solution built upon these principles to highlight how the reusable components and how a platform engineer can accelerate their responsibility to respond to application developer needs.
In this demo, we will show a few patterns we have built on an open source release called OPA on AWS that is based on the Backstage IO platform. You may be familiar with the idea of templates, how to model and approve opinionated patterns of infrastructure. We leveraged this idea and took it a step further to create hierarchy between those templates. We separate application foundations to the actual application. This allowed developers to simply deploy their application into an existing foundation. If a developer selects a particular template of the application, all he needs to do is provide the name of the application, a description, an owner, and the environment that it was going to be deployed. They simplified the process and also hide the complexity from the developer. Next, we wanted to take some of the common tasks developers do and remove the dependency of the platform engineers. One of the common tasks was to deploy an application to another environment. That process usually takes several approval processes and ticketing systems, but we wanted to make it with a click of a button. We did this by essentially allowing the developer themselves to deploy the application to another environment. Once they select a particular environment and deploy that application, a process in the pipeline will trigger. That process essentially triggers a pipeline that generates the new pipeline of which is in charge to deploy this application. At the end of this process, the developer can simply navigate or toggle between the environment to deploy by using this dropdown. But if you want to see behind the scene how we did this, it's essentially creating multiple pipelines based on the number of environments it's deployed. As I mentioned before, the idea here is a pipeline generate another pipeline that is responsible to deploy to the particular target environment. And this could be used by different types of templates. So not only one, we use it for all, whether it's Kubernetes or ECS or serverless, it's all the same principle. Next part, we wanted to be able to allow developers to attach resources to their applications without going to the complexity of managing networking or security permissions. Same as before, in this case, we wanted to simplify it to a click of a button. So in this case, we have an idea called binding. Essentially, we can bind a resource to a particular app. You can see here there is a database that is bind to this application, and we can add more resources based on what exists in that environment. But what's actually happened if we bind this? Yes, the application could read and write from that shared resource, but how does that magic happens, and how we save work for the platform engineer? Essentially, the expression of binding comes into creating a JSON statements or policy statements that express the grant of that resource. In this case, you can see it's granting access to this specific RDS, along with the secrets that manage access credentials to this database. But how this happens is basically once these permissions are created, it automatically triggers the pipeline in the .ac directory so that the pipeline will pick up those changes, apply them to the identity of the application, and essentially grant access to the application. For more sensitive environments, this process could be made by using merge requests, so you can control and approve things before they get binded. This allows developers to simply add more resources to your application without having the need to go and submit tickets and do this process again. We hope you enjoyed this demo and that you find it useful, and I hope you have a good day.
The real issue is, I'm going to try to do Q&A, or at least, and we'll make it more of an open discussion since we don't have the speaker to answer. But I'm going to do them after each of these. I think they're both short. They're about 12-minute, 15-minute sessions. So we'll do both of them. And then that should take us, well, we're running a little late. And then we'll try to do the fireside chat before lunch. All right, our next session.
Hello everyone, and welcome to PlatformCon 2024. My name is Ricardo Castro, and today we're challenging a misconception that seems to be gaining traction in the tech world: the idea that DevOps is dead. I'm here to tell you that not only is DevOps alive and well, but it's more critical than ever for software success in 2024 and beyond. So what do we have on the menu for today? We're going to talk about DevOps, what it is fundamentally, and why it's not dead. We're also going to cover how platform engineering and DevOps go hand in hand. Let's dive in. You might have heard some whispers that DevOps is dead, replaced by, air quotes, newer concepts like platform engineering. You probably heard things like DevOps is dead, or even platform engineering is the new DevOps. But let's set the record straight. These are not mutually exclusive ideas. DevOps is not on its deathbed, and platform engineering is not its replacement. A primary reason for this is the rise of other practices, like platform engineering, leading many to believe that they are the new, shiny successor to DevOps. But to truly understand the reality, we need to delve deeper into why this perception exists. And we're here to challenge this narrative. Several factors contribute to this misconception. First, the sheer number of DevOps tools available can lead to decision paralysis and implementation challenges. Second, shifting to a DevOps culture requires breaking down traditional silos, which can be met with resistance within organizations. Additionally, the excitement surrounding new practices like platform engineering can overshadow the ongoing relevance of DevOps. And finally, a lack of understanding about the relationship between DevOps and platform engineering can fuel the idea that one is replacing the other. At its heart, DevOps is not about specific tools or technologies, but it's a radical shift in how we approach software development and delivery. It's a mindset, a culture that emphasizes breaking down the traditional silos between development and operations teams. Imagine a workplace where developers and operations engineers aren't just throwing code over the wall to each other, but are working hand in hand, sharing knowledge, and taking joint responsibility for the entire software lifecycle. That's the essence of DevOps. Collaboration is key. DevOps encourages open communication, frequent feedback loops, and a shared sense of ownership over the final product. This leads to a more holistic understanding of the software from its initial design to its deployment and maintenance. Another crucial element is automation. DevOps teams leverage automation to streamline processes, reduce errors, and speed up delivery. By automating repetitive tasks, teams can focus on more strategic work like innovation and problem solving. Ultimately, DevOps is about fostering a culture of continuous improvement. By embracing feedback, learning from mistakes, and constantly iterating, teams can deliver software that meets users' needs and exceeds expectations. This cultural shift has been the driving force behind some of the most successful software companies in the world. DevOps is not a rigid framework. It's a mindset that evolves with the times. It's important to remember that DevOps has never been static. It has continuously adapted to new challenges, from the rise of cloud computing to the growing emphasis on security and compliance. At its core, DevOps is about fostering a culture of collaboration, automation, and continuous improvement. And in today's fast-paced software landscape, these principles are more important than ever. DevOps remains essentially for enabling continuous delivery, ensuring that software is released quickly and reliably to meet evolving customer demands. We must be willing to adapt our practices, embrace new technologies, and continuously improve our processes to stay ahead in this ever-changing landscape. Embarking on a DevOps transformation is not without its challenges. It is a journey, and like any journey, there will be obstacles along the way. But with the right mindset and strategies, these challenges can be overcome. One common hurdle is cultural resistance. Shifting to a DevOps culture requires breaking down traditional silos and fostering collaboration between teams that historically worked independently. This can be met with resistance from individuals accustomed to working in isolation or from those who fear change. Another challenge is the skills gap. DevOps requires a diverse skill set encompassing everything from development and testing to infrastructure and automation. Organizations may need to invest in training or hire new talent to bridge this gap. The sheer complexity of DevOps tools can also be daunting. With a plethora of options available, choosing the right toolchain and integrating it into existing workflows can be a significant undertaking. However, these challenges are not insurmountable. Here are some proven strategies for success. Start small. Begin with a pilot project or a small team to test out DevOps practices and gain valuable experience. Focus on culture. Foster a culture of collaboration, open communication, and shared ownership. Encourage experimentation and learning from mistakes. Invest in training. Provide training and development opportunities to ensure your team has the necessary skills to succeed with DevOps. Choose the right tools. Select tools that align with your organization's needs and integrate well with your existing infrastructure. And of course, continuous improvement. DevOps is an ongoing journey. Continuously evaluate your processes, measure your progress, and adapt your approach as needed. By addressing these challenges head-on and implementing effective strategies, organizations can successfully navigate their DevOps journey and reap the rewards of faster, more reliable software delivery. The software landscape is undergoing a seismic shift. The pace of businesses is accelerating at an unprecedented rate, fueled by the digital transformation of the ever-increasing reliance on software in every aspect of our lives. In this hyper-competitive environment, organizations that can quickly adapt and deliver innovative solutions are the ones that thrive. Also, customer expectations have never been higher. Users demand seamless experiences, and instant gratification, and continuous improvement. They expect software to not just be functional, but delightful and intuitive. Meeting these expectations requires a nimble development process that can rapidly respond to feedback and incorporate new features. At the same time, competition is intensifying. New players are emerging, challenging established companies with disruptive technologies and business models. To stay ahead, organizations must constantly innovate and find ways to differentiate themselves. This requires a development process that is not just fast, but also adaptable and capable of pivoting quickly in response to market shifts. DevOps is the answer to these challenges. It's the key to unlocking the agility and innovation needed to succeed in the digital age. By breaking down silos, automating processes, and fostering a culture of collaboration and continuous improvement, DevOps empowers teams to deliver software faster, with higher quality, and a great customer satisfaction. So, what does DevOps enable organizations to do? Accelerate time to market. Get new features and products to market faster, gaining a competitive advantage. Improve quality. Reduce errors and improve the overall reliability and stability of software. Enhanced customer satisfaction. Deliver a superior user experience through continuous feedback and improvement. Increased efficiency. Streamline processes, reduce waste, and optimize resource utilization. And last but not least, foster innovation, creating a culture where experimentation and risk-taking are encouraged, leading to breakthroughs. In the face of accelerating change and relentless competition, DevOps is not just a nice-to-have, it is a must-have. It's the foundation for building a sustainable software practice that can meet the demands of today and adapt to the challenges of tomorrow. Turning our attention to platform engineering. Platform engineering focuses on building the robust infrastructure, tooling, and automated workflows that DevOps teams need to excel. Think of it as the foundation on which DevOps practices are built. Platform engineering provides the self-service capabilities and environments that enable developers to be more productive and deliver software faster. DevOps and platform engineering are two sides of the same coin. DevOps brings the cultural shift and focus on collaboration, while platform engineering provides the technical foundation to make it happen. They work together seamlessly to create a high-performance software delivery machine. They're complementary, not competitive. Let's recap. DevOps is about culture and collaboration. Platform engineering is about the technical foundation that enables DevOps. The world of DevOps and platform engineering is constantly evolving. New trends and technologies are emerging all the time, such as GitOps, DevSecOps, AI-powered automation. And to stay ahead, organizations must embrace continuous learning and adapt their practices to leverage these advancements. The future is bright for DevOps, and I am excited to see how it continues to shape the way we build and deliver software. Whether you're just starting out on your DevOps journey or looking to take it to the next level, I encourage you to embrace the principles and practices that have proven to drive success. Collaborate, automate, and continuously improve. And remember, platform engineering is your ally in this endeavor. By working together, you can deliver amazing software experiences that delight your customers and drive your business forward. As we wrap up, let's quickly recap the key takeaways from today's talk. DevOps is not dead. It's alive and thriving, and it's more important than ever for software success. Remember, DevOps is about fostering a culture of collaboration and continuous improvement. Platform engineering provides the technical foundation to make that happen. By embracing these two powerful approaches, you can achieve faster, more reliable software delivery that delights your customers and drives your business forward. I hope I've dispelled the myth that DevOps is dead. It's alive, evolving, and essential for software in the modern software world. Let's embrace the DevOps mindset, leverage the power of platform engineering, and unlock the full potential to deliver amazing software experiences. And this was all from my part. Thank you for attending my talk, and I hope it was informative for you. Have an amazing day and enjoy a great conference.
Sure. In the opening panel, which is none of these movements, DevOps, platform engineering, SRE, DevSecOps, none of them are mutually exclusive. They're all part of this agile, they're all part of this continuum of the, working in the software development lifecycle. And just because you're a fan or a proponent of one doesn't necessarily mean you're crapping on the other ones, right? They're all together, and this, you've got to make it work. Now, I will tell you, being obviously publisher of DevOps.com, we watch the DevOps numbers pretty closely. Searches around the term DevOps or DevOps types of, CI/CD and, DevOps related topics are higher than ever. They continue to go up. Our readership on DevOps.com continues to go up. Share of voice, any metric you want to measure, DevOps is as popular, more popular than it ever was. That being said, I don't think anyone stands up here and tells you DevOps is a panacea or DevOps is a magic bullet. One thing I've learned in a long, a lifetime in technology is there are no magic bullets. There are things DevOps helps us with. There are things that DevOps screws up, right? One of the things was this whole shift left and put everything on the developer, I think. I think we put too much on the developer, right? They're not a security pro. They could be a security champion. I think someone mentioned that term when they were up here, right? They can be other things, but don't expect them to be a security professional. Don't expect them to be a testing person. Don't expect them to be a platform engineer, right? It's different roles, but we all have to work together to make that work. That's a really good question. Will it change with AI? AI is going to change everything, but I don't think fundamentally that changes. I think AI helps the developer an awful lot in developing and being faster, better. You know, I had this conversation with my children to tell you, they're adults now and they're out in the world, right? You could be afraid of AI and watch it take your job, or you could harness AI and become 10x more effective. So is it going to change with AI? That depends on you. Are you willing to embrace AI to become 10x what you are? Or are you kind of afraid of or intimidated by AI and you're going to watch it kind of roll over you? I think smarter people are going to embrace it. It's not going to fundamentally change developers. It's going to make them more effective. It's going to make platform engineering, I mean, almost, you know, at its root, platform engineering is setting up the environment, setting up the platform, and putting in these automations that allow these things to run. That's a perfect role for AI, right? That's a perfect kind of place for AI to come in there. Another observation, platform engineering is very much about platforms and tools. If you listen to the people who were behind the DevOps movement, people like Patrick Dubois, John Willis, and Gene Kim, and so forth, DevOps was never about the tools. It's, you know, yes, we have CloudBees, and we have, you know, a lot of the DevOps tools vendors out there. But DevOps was cultural, number one, right? It was about breaking down the silos of developers working with operations, with security people, with testers. And if you're just thinking that DevOps is about tools, well, then you're going to say DevOps is dead because it's not just about tools. And it's the same is true for AI. DevOps is not going to be just about AI, and developers are not going to just be about AI. They're a piece, they're a tool. That's how I got into technology in 1992. I went to law school, so lawyers loathe technology, right? We're terrible, troglodytes. And we didn't even use Microsoft Word. We used Word Perfect. That was the word processor. Yeah, right? I became the Word Perfect expert in my office because not even the secretaries or the lawyers, they didn't want to use it. They were on IBM Selectric computers, typewriters. So, and I got into first Word Perfect, then into Novell networking, and then when the internet went commercial, I left all that behind and got into the internet. But yeah, it is akin to that. If you're it's a tool. If you think of it as a tool and you harness the tool, that's what makes, right? That's what lifted humans out of the savannas of East Africa, right? Or so they say. So I do think, you know, DevOps is far from dead. DevOps has a very tight integration into platform engineering. They're not mutually exclusive, and I agree wholeheartedly with Ricardo's session there. Does anyone have any comments on that? Because if not, we've got this next one. Let's key it up. Yeah? All right, we'll do this one, and we'll see what time looks like. Okay.
Thank you for joining this PlatformCon 2024 Impact session, where I will discuss the impact of platform engineering in a hybrid world. My name is Drew Pyland, and I am a Senior Product Marketing Manager at CloudBees. Over the next 15 minutes, we'll cover a few topics, starting with the hybrid landscape that affects all organizations. Next, we'll briefly provide an overview of platform engineering and its impact on the developer experience. And we will conclude the session with some practical guidance around common pitfalls and best practices to consider when adopting platform engineering. So when speaking with customers, a few business issues appear constantly. The first is around needing to decrease the time to market by boosting developer productivity. The next is around enhancing security posture across the software development lifecycle, whether from a security, governance, or compliance perspective. The next is around reducing costs while improving the overall service quality, which essentially is doing more with less through operational excellence. These issues themselves are not new, but they continue to be amplified as a result of the cloud transformation mandates that are being placed on organizations to modernize their software delivery infrastructure, which presents some additional complexity and nuance in achieving these goals. When dealing with cloud transformation, there are two fundamental truths we want to present. The first is that hybrid is a journey. According to Gartner, only 30% of enterprise workloads have moved to the cloud, and this number will not reach 50% until the year 2027. This means that while organizations continue to evaluate their cloud transformation strategy, they must ensure on-prem is included as part of that story for the foreseeable future. The next is that cloud applications are heterogeneous. They come in many forms, whether this is cloud native, lift and shift, or refactored. It is essential to understand the pros and cons of each of these approaches when evaluating how to modernize your software application portfolio. These facts present environmental complexity, which can be costly in many ways. Most notably, there's a direct impact on developer productivity. Recent stats have shown that developers only spend 32% of their time writing code. And if time spent writing code is how you measure developer productivity, then organizations have a lot to do to get this number higher. Succeeding in hybrid requires autonomy, letting teams select the right tool for the job while providing proper oversight. It's about continuing to support traditional applications for mission-critical work, but letting teams explore cloud-native applications to benefit from cloud efficiencies. By tying these things together through orchestration, you unlock centralized insights that are critical to maximizing developer time by spotting bottlenecks quicker, focusing on value-added tasks, and removing blockers. Platform engineering teams play a critical role in achieving these business outcomes. Platform engineering is an emerging discipline dedicated to reducing complexity and cognitive load for DevOps teams. So how does this differ from DevOps? Well, first, DevOps is not a role, but it is a way of working. It is a cultural movement designed for shared ownership and collaboration to achieve a common outcome. Platform engineering furthers DevOps by providing common services across the enterprise with abstractions to key infrastructure and tools that eliminate complexity and facilitate rapid adoption by the development team. Stated another way, platform engineering is about driving efficiencies within DevOps. And a recent study conducted by CloudBees showed that 94% of respondents agreed that platform engineering helps realize the benefits of DevOps. The goal of platform engineering is to optimize the developer experience and accelerate the delivery of customer value. Platform engineering teams treat your platform as a product and your internal teams as the customers. By dedicating themselves to improving developer experience, platform engineering teams allow DevOps and SRE personnel to focus on writing code instead of operational overhead, which results in happier developers. And Atlassian states that 76% of developers are happier when they have greater autonomy and flexibility into their tooling and are not forced into a specific tool set. Platform engineering teams often achieve this by building and operating self-service internal developer platforms, or IDPs. To succeed, they must optimize these systems for what their end users, the developers, ultimately want. And often this falls into four buckets. First, it's a means to rationalize their open source strategy. and to handle the bureaucracy that comes with licensing open source. Second is around codified service patterns or designs so that developers can choose from a toolbox or design patterns that architects have approved and generally linked to. Third is around golden paths or templates, which could relate to pipelines, pipeline flows, security scans, policies, you name it. And fourth is around the last mile of operation and supports, which involves documentation, runbooks, and potentially giving operations some visibility into the pipelines. So when dealing with the decision of whether to build or buy, it is important to evaluate the needs of your developers and your business. Start by asking yourself, is it a strategic enabler for your business? If the answer is yes, I would advocate building it. However, in most cases, organizations would say that tool chains and some software development lifecycle aspects are a means to an end. This is an area then where you should likely buy and assume those core capabilities via a vendor and then build your strategic enablers on top of that. Another consideration is your time frame for demonstrating value. And how are your resources set up to support this? While building offers ultimate flexibility, it creates a longer time to value and higher overhead. By buying a solution, the need to support, build, and manage it from scratch goes away. You also benefit from having a large development team and a potential community behind you. So now that we've defined platform engineering, I'd like to provide some context into the current state of it based on a recent study conducted by CloudBees. Platform engineering is gaining traction as 83% of organizations are currently in adoption mode. This supports Gartner's claims that by 2026, 80% of large software engineering organizations will establish platform engineering teams as internal providers of reusable services, components, and tools for application delivery. Since platform engineering is a newer discipline, we asked where this fits in the broader organizational structure. Cloud engineering and cloud centers of excellence were the most common response, and this makes sense. When you go back to the cloud transformation stats shared earlier, organizations realize that platform engineering is crucial to helping make the transition while keeping the developers first. Next up were the infrastructure teams that came in at 25% of the response, followed by development teams at 20%. Regardless of where they sit in the organization, it's essential to understand that their sole charter is around reducing complexity and cognitive load for the development teams. As we continue into our survey results, it should be no surprise that developer productivity is a critical adoption driver for platform engineering and is the primary metric used to measure its success. Second was around the management of CI/CD pipelines. And then you start to dive into other areas such as tool chain simplification, standardization across tools and processes, and the impact that all this has on reducing costs, enhancing security, and improving overall system resilience. With that in mind, let's shift from academic to more practical guidance that you can use. When looking at common pitfalls, the first one that comes up is around short-term planning, and this has a massive downstream effect. Platform engineering teams often start by supporting a single team ad hoc. This is not sustainable, as it will result in each line of business ending up with its own silo of tools and processes. And over time, that's just additional technical debt that is building up. Questions that teams should consider earlier in the process include, how can these processes scale across the organization? How can we ensure flexibility in the tooling and APIs to avoid lock-in? How do we promote standardization for processes to create consistency? And what is our plan for implementing security along the way? Failure to plan leads into our second downfall, which is the most common, which is a lack of overall investment. Like any successful product, IDPs require sustained investment to be successful. This investment will grow over time and will eventually reach the C level for approvals. And if you plan for this, then you're in trouble. A major pitfall is the inability to show the strategic impact on the business. This is not because there isn't value, but because it has not been properly communicated. Platform engineering teams must never forget this and gather evidence of how they are helping to drive the business forward. The last pitfall is around adoption. And to steal a line from the classic baseball movie Field of Dreams, if you build it, he will come, isn't a given for platform engineering teams. Just because you build an IDP doesn't mean that developers will automatically flock to it. Developers are an opinionated group, and you must continuously demonstrate value to gain their adoption. This is a multifaceted issue, because even if you gain their initial adoption, you'll then face another challenge. The reality is that the demand for platform engineering teams will often far outpace supply. Platform teams will evolve from team-specific to a centralized function that comes with organizational demand. And this is where you get into potential funding challenges due to the finite investment levels. This results in platform teams sometimes struggling to keep up with developer demand, which could lead the developers to then explore other alternatives. Now that we've covered some of the common pitfalls, let's address best practices for how you can avoid them. The most successful companies have treated IDP investments like full product development. As with any product development initiative, you identify where your customers have pain or friction points. Then you consider abstractions to enable them through self-service or your platform team. The first best practice we have is to focus on small wins first and grow from there. Successful business outcomes are achieved by balancing people, processes, and technology. Platform engineering teams will have finite resources to address seemingly infinite requests. Prioritizing quick wins is of utmost importance, especially early on. The second best practice is around communicating your wins to gain adoption. Celebrate your wins early and expand as hypotheses are proven. Prove that you're receptive to developers by incorporating their feedback, demonstrating how you're making their work more fulfilling, because happier developers are more likely to adopt your solution. Developer adoption is critical in the long run for securing executive buy-in to make your case for continued investments. To ensure these investments, you must quantify business impact of these wins. How much faster are teams releasing software? Is the quality more secure? And are you operating more efficiently? The third best practice is around keeping the focus developer-centric. Treat your internal developers like they are paying customers with plenty of other options should you not meet their expectations. Ensure their feedback gets incorporated in future cycles and make it extensible and flexible, often through the use of APIs. To summarize, cloud mandates have added complexity across people, processes, and technologies. Developers are instrumental in releasing features faster to market, but repetitive tasks continue to hamper their productivity. Platform engineering teams have been formed to help organizations realize the value of DevOps by reducing complexity and cognitive load for developers. Organizations commonly struggle due to short-term planning, limited investment, and a general lack of adoption. In order to avoid these, some best practices include focusing on small wins first, being sure to over-communicate these wins, and keeping the focus developer-centric. I recommend using a bottoms-up and top-down approach in this regard. Thank you very much for your attention in this session.
I don't know if anyone had any thoughts, comments you want to share on that, or no? All right, here's what I'd like to do then. We have a fireside chat with Francois and I, which I've been looking forward to, and we get a chance to meet Francois in a second. Looking at where we are with lunch, let's do that. I think it's about a half hour, 40 minutes, and then we can break for lunch, and that wraps up. We consolidated without the sonotype, Brian Fox here. So feel free to have lunch and have your afternoon back to get some work done. Or not, that's up to you. So Francois, if you would come up, if I move these chairs, do I mess up the cameras, Brian? Yeah. Yeah, I got the mics here. Yes. Folks, everyone sitting back in near the bar area, if you guys would like to come on up here, we'd love to have you. Let me just bring up my Francois stuff. Okay.
Where is the fire?
What?
Where is the fire?
Where's the fire?
Yeah.
No, there's the fires are breaking out all over the place.
Okay.
Let me do this. Does it work? Yeah, okay.
Yeah.
Okay. Are we, well, they probably need to adjust the camera here.
Good.
Okay, so we should start with an introduction. So as I mentioned earlier, I started DevOps.com about 10 years ago. And our first two sponsors of DevOps.com were a company called AppDynamics, AppD, which eventually got bought by Cisco, and the good folks at CloudBees. It was, back then, I think Jenkins was about 85% of the CI/CD market were folks using Jenkins, and the folks at CloudBees were Sasha Labouré, who was the CEO, is now Chief Strategy Officer. This gentleman here, and 10 years, I still don't pronounce his last name right, but Francois Duchouet?
Yes.
Close?
Yeah, close enough.
Okay, so I always call him Francois. And of course, back then, Kosuke, KK was Chief Science, or maybe he was CTO back then. And DevOps was a very different world. It was a interesting and dynamic, and the excitement was palpable. And it still is, but it's changed certainly over the last 10 years, right? And as CloudBees has changed over the last 10 years. Francois, before we even get to the questions that we have, I wanted to give you a chance to talk about this evolution of, and let's do it, the evolution of CloudBees over these 10 years, but in the backdrop of the evolution of DevOps, right? What it was then, what it is now, how it relates to things, as we've been talking here at PlatformCon, like platform engineering and SRE, DevSecOps. So if you wouldn't mind, from where you sit, and you have a pretty good cat's bird seat at it,
yes,
what do you see?
Well, I think that if you think about whether DevOps or platform engineering, these are kind of disciplines. And many of them, they existed before there was a name for them. So in a way, when the word DevOps was coined in 2009, people were starting to DevOps before putting a name on it. And then, people just took a step back and said, well, what we're doing here is interesting. It should become more of a discipline, and we should codify it. We should define the principles of it and put a name on it. So DevOps came up. But then, of course, it's a living organism. It has to change all the time. It has to adapt. So CloudBees being part of that movement and part of the market, we were both a player and an observer of the evolution. And, we'll talk about platform engineering in a minute. I think it's a bit of the same thing. Platform engineering, people were trying to implement some of the principle of platform engineering before it became a codified discipline, and it's a codified discipline and is still evolving itself. So what we saw, the change I think we saw, is very much related to what some of the things Drew was talking about a minute ago. I think that those disciplines apply to a physical world, a real world that has been evolving a lot. And I think that the biggest backdrop of both DevOps and platform engineering is the cloud transformation, and more recently, of course, AI, but the cloud transformation. And I'm talking about it because if you think about the reality of companies 15 years ago, especially large enterprise, regulated enterprise, the cloud didn't exist for them. And as you saw on a slide a few minutes ago, even today, 30%, 35% maybe maximum of the business application are running in a cloud, and even some which are running in a cloud today are not really cloud native. And so what happens is that people are starting to adopt the principle of DevOps, which has been said many times, is a way of working, is a way of organizing your team. It's not really about technology. as opposed to platform engineering. So companies had to deal with DevOps with traditional application, and then they started to apply DevOps to cloud-native application. And you could say, well, it's a discipline, so why does it matter? Because it's just principle of working, ways of working. Except that when you implement those principles into processes, into actual activities, you are going to deal with the reality of those applications. And everybody who is a practitioner today can see that you don't implement the principle of DevOps with a traditional application, with a monolith application, the way you do it with a microservices container-based application. Because at some point, the reality of the application, the way you build it, you test it, you integrate it, you deliver it, is different. There's a reason why people who are managing big monolith application are not delivering 10 times a day, because it doesn't make sense. As opposed to, yeah, you have an application with 20 services, microservices, that are loosely coupled and independent of each other, then you can push them every day, maybe 5 times a day. It doesn't matter, because the other services will not be impacted.
Right.
So the physical reality of application at some point has an impact. And I think that all of the things that we try to improve and implement as best practices for DevOps or best practices for platform engineering are at some point hitting that thing, which is this transformation. So, say differently, when you want to implement DevOps or platform engineering in a static world, it's relatively easy because the thing is not moving all the time. But every company here, and I have the pleasure to know some of the people at those companies, they have to deal with a world that is changing under us.
It's a moving target.
All the time. It's a moving target all the time. So it's not easy from that perspective.
Listening to you, I'm reminded of this. One of the things that again, mistakes we've made along the way in DevOps is that somehow the goal is 10x a day, do 10 releases a day. If you're coming from a culture where you used to release software once a year, twice a year, quarterly, let's say you release software quarterly and you go to monthly releases, that's a huge uptick of being able to release. To go to 10x a day, most companies, most applications don't need 10x a day. I think we've kind of given ourselves a false goal to when we say, yeah, we want to do 10x a day. Yeah, you might, if you're in a microservices architecture, you're updating some of the services, that are isolated as their own thread. Great, but how many applications really need that 10x a day kind of thing? And is that a false? We've got a question already. Come on up here so we can hear you. In a microservices environment, yes, but you don't update the whole thing. You want, yes, threads need to be updated. But because and assuming it was architected correctly, you can update a single thread without necessarily disturbing the entire application. And I think that's the tribute, an unheralded asset in microservices. Francois, you want to comment?
Yeah, and the other thing behind that is that microservices applications are definitely a great model for a certain type of application. Doesn't mean that every application will become a microservices container-based application. It's a growing space, and it's accelerating, and there are millions of applications in the backlog around the world waiting to be transformed. But some applications will not become that. And even some of them might be modular, but will not be delivered this way. I mean, think about the huge amount of applications that are embedded applications. Embedded in network, embedded in medical devices, embedded in phones, all kind of devices that that will a car, embedded in a car, embedded in a plane. When you do these kind of things, you don't change it 20 times a day. It doesn't make sense. So there's a place for monolith, there's a place for microservices. And I think, again, when you think about, and when we cloud-based think about the technology we provide to facilitate the actual implementation of DevOps principle or platform engineering principles at companies, we embrace that hybrid nature of application. Because what sometimes is surprising to me when we talk in the industry about what are the challenges, I think we don't talk enough about that. Because at the end of the day, what DevOps or platform engineering is helping do is helping people build, test, and deliver application. The thing we manipulate every day is application. And we manipulate very different type of application. It would be like in manufacturing, you talk about manufacturing, and think that manufacturing of a chemical product or of small packages or a plane or a boat is the same type of manufacturing and the same type of supply chain. It's not the same. So we have to embrace that hybrid nature of application.
I think it was in one of the presentations from PlatformCon that we won't reach, the goal is to reach 50% of applications moving to the cloud, I think by 2027. That's not 50% of applications transformed into a microservices type of architecture. That's just cloud washing them, right? That's just moving them to the cloud, but probably still on monolith. So what we need here, and that, we all live in a bubble where, of course, why wouldn't you adopt platform engineering? Of course, we've been using DevOps for a number of years. Of course, cloud native, and we're on Kubernetes. But one of the things I think we forget is that at best represents 50%, at best represents 50% of the addressable market. Half or more of the market has not gone cloud native, does not have platform engineering teams in place, hasn't really adopted DevOps. Maybe they've dabbled. I think 70% of organizations might have experimented with DevOps, like kids experiment, right? So I think we lose sight of that fact.
Yeah, and I mean, at the same time, it's a fact that the growing part is the cloud native part. So that's the one that's growing, the one that's expanding, where there is more innovation, because by definition, a lot of the monolith applications are relatively stable and mature. So that's also why they don't necessarily have the same pressure to deliver in production so often. So we should not lose sight that there's one part of this equation which is moving and evolving faster. And I think to some extent, even if platform engineering, for example, is definitely for both type of application, it was more born out of the requirement of the cloud transformation. And for DevOps, I would recommend this. One of the books on DevOps that I think is one of the most interesting because it's a lot of fact. It's based on a lot of data research. It's called Accelerate. It was published, I think, in 2019 or 18 by Nicole Forsgren and a few other luminaries who are behind the DORA matrix, for example. And in that book, there is one paragraph, I will not quote it, but it's one very specific paragraph where they really highlight the fact that the speed of delivery is very much correlated to the fact that you are delivering cloud-native application. So it's back to what we were talking about before. So DevOps applies to everything, but if you want to accelerate, you have to have this kind of components underneath. Otherwise, you can still do very good DevOps implementation, but without the same expectation.
Francois, if it's okay, I want to pivot a little bit. So we talk around, with platform engineering, we talk about an internal developer platform. And I know CloudBeast, for instance, recently released a platform, well, not recent, it's probably 6 months, 8 months ago. talk to me about what do we mean by internal developer platform? Is that part of platform engineering? And is that DevOps? Where does that fit? Or is it just something else in and of itself?
Yeah, well, I would say that the IDP, the internal developer platform, is in principle the outcome of platform engineering implementation. So that's the physical manifestation of platform engineering. And I think, at the end of the day, sometimes technology people are criticized because they do tech for tech. Platform engineering is not tech for tech. Platform engineering, at the end of the day, has to achieve one goal, is to help developer produce code faster and in a safer way. Why? Because a lot of the innovation of businesses is delivered now through software. So nothing's new here, but platform engineering has no other goal than that. And in a way, DevOps, the way of working, the way of organizing teams differently, was also to unlock productivity, unlock innovation, etc. So whether you talk about DevOps or platform engineering and IDP, it's all about faster productivity and faster innovation for the business. So there's nothing, we have definitely a complete shared objective. And of course, for that, you have to have certain attributes to enable that productivity. One of them is providing, like it's been said many times, the ability for developer to have a self-service experience, not having to actually ask or talk to people, because otherwise, you slow down things by definition. So self-service is one of the attributes of an IDP. Another one is you need unified and integrating tooling. If you have to deal with integration yourself, or if the tools are not unified, you're also going to slow down your productivity. A third one is, of course, security and compliance. We talked about it many times this morning. Security and compliance has to be taken care of by the IDP. Then if you talk about the developer experience, which is a very vague term, but if you think about some practical aspect of developer experience, ease of use, of course, is important in an IDP. Access to resources, not just automated function, but also documentation, training, everything that is part of something that you, as a developer experience, you need information, you need support, and also things where you meet the developer where he is, and not you don't force the developer to come to tools. The tools and the meaningful part of the tool has to come to the developer. So that's really the developer experience. So that's another one. And then another one that I think is very important, and it was mentioned by different people. I think by Zahib, it was mentioned earlier, the extensibility. Extensibility is very important. You can say customization, but the fact that in a way you could say a platform is not a platform if you cannot extend it. It's not really a real platform. So, those 5 things I think are really the key attribute I think that matter when you. And one thing I want to say also before we move on another question, there is sometimes, not always, a confusion between the portal aspect of a platform, because both have the same acronym, IDP, ID portal, or IDP, ID platform. Mm-hmm. And for me, the ID portal is part of the ID platform, and it's one of the facilitators of a self-service experience, but it's the tip of the iceberg. And I think, again, the AWS presentation was very interesting from that perspective, because it was showing that what you build under the portal, is very important. It reminded me of something that people who were already in a business in the 90s, the first generation of e-commerce system, people were very focusing on the e-commerce aspect of it and were ignoring, in a way, the logistical aspect of e-commerce. And so people thought that because they had a cool e-commerce front end and a cool way to buy things, they had figured out e-commerce, except that the delivery aspect was sometimes falling apart. And by the way, there was a company at that time who figured that out better than anybody. It's called, I think, Amazon. You've heard about them?
Yeah.
Yeah. So they were the one who are just not have the e-commerce front end, but they figured out the logistical behind it. And as a coincidence, 30 years later, they are the leader. So I think in a platform, in an IDP, you have the portal, the visible part of it, that is very important. But sometimes if you think about, I have Backstage, I do IDP. Well, you do ID portal, you don't do ID platform. And so the two have to work really well together.
Excellent. We talked about it earlier today. You mentioned on it too. How do you see the relationship of platform engineering and DevOps?
Yeah, so it's been said, I think, very well this morning. So it will make my job easier here. But yes, I think at the end of the day, DevOps is the way of working, is the way to organize your teams, is the way to collaborate, and platform engineering is providing a more robust and a broader set of technology working together in a certain way, following some principles that facilitate the implementation of best practices of DevOps. That's why, I fully agree. I had the same thought of the other two faces of the same coin. In a way, one of the mission of the platform engineering is to facilitate the implementation of DevOps practices. And there was actually an interesting communication by Caspar von Grünberg, the CEO of Humanitech, who talked to Kelsey Hightower recently. I think it was published just last Friday, before PlatformCon, where they had a kind of a provocative title saying, "Silos are great," or "Silos are amazing," or something like that. And I think the point they were making that I kind of agree with is that, yes, there were silos because like every organization at a certain scale, you start to specialize people. So as soon as you are not a startup with 5 people anymore, you specialize. People only develop, people only do QA, people do only ops, people do only this. Security, because that's the nature. In every organization at certain size, you specialize. And you create silos. So of course, silos is a problem because then you create bottlenecks and lack of collaboration. So DevOps came up and said, let's break down and let's create a horizontal where you have in every team a representative of every function, which is great on paper, but it's not always easy to do because can you really spread a security person or you have any... So it's not so easy to do when you have to do it in a real life, in a physical world with people with certain skills at some point. And so their point was, well, actually, if you think about those functions, they have very much specialty function. What matters for them is that to expose themselves with API to others. And the more you think about, my function is there to expose API to the other, you are thinking platform engineering. And there's nothing against that contradicts DevOps principle because, again, this is not the same thing.
Absolutely. So, Francois, let me ask you a hard question that when you look specifically at the CloudBees customer base, you guys have hundreds, if not thousands of customers, hundreds of thousands of people, working in CloudBees. How widespread, how widely adopted is platform engineering and platform engineering teams within the customer base?
So yeah, we have customers in every industry. We have in particular a very large set of customers in the financial industry, in the insurance, but also in technology. Some of the largest software company today delivering SaaS system, for example, in CRM or in ITSM, I won't say names, are actually building, testing their software with CloudBees. So a lot of constraint, a lot of security, a lot of regulation. What we see is that, as I said before, people have started to create platform, IDP, or maybe, embryos of IDP before platform engineering became a discipline. So a lot of people, when we talk to them, we realize they look at platform engineering like, oh, now I understand that what I was doing was going into the right direction. But platform engineering brings a much more complete picture with principles, with guidelines that help them get to the next level. So for me, platform engineering is a kind of a next level of something that people were doing before, but now it's more codified, there's like, best practices and people who can really help. So I think it's just an evolution. There's a continuum between what they were doing before and next. I would say again, as I said before, I think the thing that's slowing down the adoption of those principles is the fact that the world below them is evolving and have so many things to do that it's just moving from one environment to another, changing the technology. What application do I have to lift and shift? What application do I have to refactor completely? What does it mean for the infrastructure? So they have to adopt this principle, they have to adopt this technology in the middle of very evolving things. So I would say that I don't see anybody resisting. I don't see anybody not understanding. It's like they all get it out of the box. It's more that it takes time to implement them. I mean, that's why, look, the cloud. AWS first services were in 2006. 18 years later, we are talking about the fact that 30% only of the workloads are in the cloud. So every time, we have the same always thing happening in technology, we think that things will be adopted tomorrow. It takes a lot of time, but I think everybody is getting there. I don't see anybody going against it or resisting it. It's more a matter of how much time, how many resources can I get to do that while still serving the business every day.
I think that's an excellent point. In your position as co-founder, strategic initiative sponsor, I founded 4 or 5 venture-backed startup companies. We lose sight of the fact that in a world where we're striving to do 10x, releases a day, exactly how long it really takes for technologies to reach critical mass, to really become de facto standards.
Yeah.
Where a lot of us are early adopter kind of folks, and we gravitate towards the next new thing. But it's 18 years with the cloud, and we still haven't hit 50%.
Yeah.
So it is out there. But overall, and then I'll open it to the audience, it sounds to me, though, like CloudBees, along with many of the other DevOps tools vendors, are embracing platform engineering because it does improve the developer experience, because it does help us continually evolve.
Yeah.
What we try to do with DevOps and all of these things, which is to do more, faster, better.
Yeah, absolutely. So I think the reason why we build a platform that is like a core building block of an IDP is because we recognize that every enterprise today, small, medium, or large, or in every industry, is facing the same challenges. So one of them is infrastructure complexity. It was mentioned this morning. Infrastructure complexity doesn't get any better right now. In a way, cloud, because it's not replacing everything else, it's just adding another level of complexity on top of the existing complexity of older technologies, infrastructure. You still have a lot of inconsistency of environments. The famous old problem of, it works on my computer and it doesn't work in production is still there because of inconsistency of environments. So these are 2 of them. You have also fragmented tools. There's still a lot of fragmentation in the tooling. And in an IDP, you try to standardize and simplify, but you have to deal with this fragmentation. Then you have a lot still of manual processes. Everybody wants to automate, but there are some parts of the whole SDLC, and especially we talked about automation of testing. Test is still not very automated. So it's another thing. Then you have the whole security and compliance challenges that have been mentioned also many times. So that's yet another one. So all of these things, we see that every day with our customers. They struggle with that. And so we wanted to build a platform that's addressing all of those issues. And what we did is that we took almost all of these things one by one, and we tried to address them in a platform. So, for example, one of my major, if not unique initiative at CloudBees I've been working on over the last 2 years was to foster this creation of a unified platform. So sometimes the platform internally, we call it CloudBees UP, UP, Unified Platform. And it's not because unification is just a nice word or an end in itself. It's because when you have tools that participate into the platform, which are really unified, meaning the same code base, the same object model behind them. When they manipulate an application, they have the same definition of what is an application. When they manipulate a vulnerability, they have the same definition. Basically, they have the same data model. That's something that, for whatever reason in the DevOps world, has taken time to become a reality. I come from, many moons ago in the 90s, I was doing IT consulting at that time for large companies, and the 90s were the years of ERP. And I know ERP now sounds like an old world, an old system. It's still running the world, Yeah. Every transaction in everything is going through an ERP system at some point, even today. So now it's like mature technology. People take it as a given, but it wasn't a given at that time. And ERP took off when they unified the different function into one system with one data model, where the definition of a customer was the same for everybody in the company. The definition of a product was the same. The definition of a supplier, the definition of an account, all of that was not existing before. In DevOps, we are looking at that right now. It's exactly the same thing. It's like, okay, I'm a developer. My definition of an application, of a component of software, has to be the same as the other tools. And the only way to force that is to create a system where all of the existing tools who used to be standalone tools have to become not a tool anymore or a product. They have to become a capability of a platform. So once they become a capability, it means that they give up, in a way, the data model to a shared data model. And they accept to adapt and to maybe modify a bit their data model so that at least we all speak the same language. Because again, what's fascinating in a lot of companies is that each tool has its own definition of some core fundamental object. And by definition, if they don't have the same definition of what is a software component, what's an application, what is even a user, how can they communicate? How can they collaborate? So for us, the first foundation of the platform was to unify all of that, which is one of the challenges. It's not the only one, of course. Another one that we wanted to manage was scalability, because we deal with large enterprise. Or we deal with a multi-tenant system where thousands of developers from different organizations have to use the same platform. And for that, well, we built a microservices application. So our application is embracing all the cloud-native system, because that's where you get economies of scale. We build it on AWS, and we leverage the infrastructure of AWS 100% with cloud-native, very, very fine-grained services, so that we can modify, evolve it, because that's a system that has to evolve. So that one definitely has to be cloud-native. But the unification is a fundamental one, and it's not just a product-centric objective. It's because we know that if we do that, then customer benefit from that unification right away.
Very good. Guys, we have questions. So hi. You want to grab one of these? Or come on up if you'd like.
I have two questions to you, both of you. The first question, you mentioned about developer self-service. And I know it's kind of a vision that in most platform engineers we promote for developer self-service, but in reality, it always has, at some point they say, okay, up to here. From here, it's no more developer self-service because of ABC. How do you think about this? Where do you put the limit to say, okay, up until here it makes sense to do developer experience, and from here maybe not? What's your take on this?
Well, I think that in order to provide self-service, I think you have first to build the services below, because otherwise, there's no self. So I think the self-service is always going to be limited by what has been automated in your underlying platform. So it's never going to be 100%, or it might be in an ideal world. So that's why sometimes the limit of self-service is there, because some things are not automated. For example, one of the use cases of an IDP is infrastructure provisioning. It's great on paper, but as you said yourself in your presentation, the diversity, the never changing evolution of infrastructure means that maybe a developer will come and will not find what they want to do, either because it's new or because it's not been taken care of. So I think that for me that's the main limitation, is that your front end is limited by the capabilities of the back end, basically. So I think that's one of the and the back end is always catching up, again, because the world in where we are evolving is still catching up. There are also parts, back to the hybrid nature I was talking about in an enterprise. Maybe you want to automate things for cloud provisioning, but does it make sense to create a function for a mainframe or for, things that, so there are limits also based, again, on the very hybrid nature and fragmented nature of the underlying infrastructure.
I have one more question. Thank you first. You talked about a topic that I kind of recently encountered too, about the problem of a unified platform, in a sense, so how to connect pieces. Is there, who do you think should maybe create this initiative, or to create that standardization across components, apps, technologies? There's so much to it.
So I think before we decide, I'll stand up here. Before you decide who should create that unified platform, I think you got to take the threshold, which is, should you have is a unified platform even possible? Because in real life, right? In real life, especially at the enterprise level, it's very hard to get standardization across an entire enterprise on a lot of the tools within that platform.
Just to sharpen the bit, I'm not talking about unified platform, I'm talking about unified standard. Okay. Whether implementation of that standard, one platform can implement one way, another platform.
Okay.
So,
fair enough.
Yeah, so first of all, the platform we have built is aiming first, because it's already a sufficiently large problem to solve, is unification. The unified data model and normalized data model that we have put together is for the heart of the system, which is the CI/CD supply chain. So that's where we unify, so that every step is codified, unified. But let's take some practical example. Unify doesn't mean necessarily that you have to use everything in the platform. Actually, that's not our goal. A practical example of that is security. So the platform we have lets you use more or less any scanner, any tool you want, open source, enterprise tools. You know, the DevOps landscape is very wide, but if you look at the security space in general, what we have done in a platform is that we have normalized the security events and exhaust pipe of security scanners. We have normalized them so that customers don't have to do that themselves. So we have a layer where we take all of the output of those security tools that the CI/CD toolchain is providing, and we normalize the output so that we can provide dashboards that do not replace the very detailed low-level dashboard of those scanners, but in the platform itself, we surface what we think matters. So what are the vulnerabilities? What are the critical ones? What are the non-critical ones? How do I get to the piece of code that... So we surface that because the developer, that's what they want to know. They don't necessarily want to go to the detail level of what tool is providing. So that's where we see the way to unify in a way that is meaningful for our customers. We are doing the same for testing right now, for example. So in every step, we don't try to tell customers, if you want to benefit from unification, you have to use our platform 100%. You use our platform, but you can still use those tools because we normalize for you. And we don't think it's the job of customers to do that. So that's why we put it in a product.
Thank you.
Good. You just put it. Another question.
Since we are talking about DevOps security and digital revolution, and who better person than to ask you, right? So can you give a quick brief overview? What is the next phase of cloud-based modernization, right? What is the next step of bringing all this together in your next platform version?
Yeah, so the platform we've built, I've talked about it at a high level. At a practical level, one of the core principles of that is we think that the world was hybrid, the world is hybrid, and the world will remain hybrid. So for us, that hybrid nature of the world, both at an infra level, cloud and non-cloud, and at the application level, traditional application and cloud-native application, is the reality of today and of tomorrow. And we see that in every customer. You know, that's what you have to deal with. And we think that the platform that we want to provide to customer has to take that as a first principle. And so practically speaking, if you think about the platform, you have to think about our strategy is to provide two levels that are complementary, but that should be completely transparent for customers. So first of all, at the functional level, all of the features that I was talking about, CI, CD, feature management, security and compliance, analytics, VSM, all of these things have to be part of a unified set of capabilities that customer don't have to worry about and not have to deal with that in every standalone product where every time you have to redefine your users, you have to redefine your integration. You do that once for all these capabilities. So that's the convenience of the platform. Now, under the hood, you have to deal with, as I say, traditional and cloud native. For traditional application, we come from the Jenkins world, which is the best system to manage this kind of traditional application because it's dealing with this diversity of very, very fragmented technology of very different type of application. On the other hand, when you want to deal with cloud-native application, you need something that is more designed for cloud-native application. So what we're providing for customers is a platform with all these unified capabilities, but when you go to the factory, at the factory level, when you have to build, test, integrate, deploy, we want to give access to different type of engines. So in the platform, you will be able to use both at the same time. Engines like Jenkins, which is still the number one, engine for DevOps, and also a tooling based on Techstrong technology, another open source engine that is well known, that was born and raised in Kubernetes. and that is designed for cloud-native application. So depending on the type of application, we want the customer to be able to use the same functionality, but trigger a different type of engine based on the type of application they want to use. And not only that, we want also people to sometimes still run those workloads on-premise when they have to, and still manage it from the platform. So the platform becomes a single pane of glass where you define everything, you have end-to-end visibility, and then you abstract away the physical reality of your application, so that every application, regardless of where they run and how they are architected, can be managed by this single platform. So that's the ultimate unification we want to bring to the customer.
When do you expect that to go GA?
Well, we have more or less, I would say today, 90% of it GA. But you know, a platform is software, so it's never finished. It's always evolving. But that promise that I've just described, 90% of it is already GA. And we are testing it right now with a number of our customers.
Thank you.
Anybody else? Yeah. Francois, I want to thank you for, well, Francois is local to New York, but thank you for coming in today and sharing with us. It's always a pleasure to have you. Guys, that takes care of our, for today. Lunch is served us, so please eat. There's plenty of food there. Take home if you'd like some even. I just want to remind people, PlatformCon does continue the rest of this week virtually. We will be doing a session on Friday. Hope Lynch from CloudBees will be there. We'll have two folks from the Humanitech team over in Europe, and I think I'm going to have an analyst from Futurum Group join me there. So if you could catch that Friday, great. Other than that, thank you all for coming today. We appreciate it, and have a great day. Bye-bye.